This is week 1, and now we're working on equations and solutions. First of all, a little bit of vocabulary. An expression versus an equation. An expression does not have an equal sign in it. It's just a term or a collection of terms. So, for instance, 2x squared plus 3x. That's an expression. It's not set equal to anything. I don't solve it. Somebody might tell me what x is, and I might evaluate the expression given a certain value for x. But an expression has no equal sign. We don't solve expressions. But if I had something like 2x squared plus 3x equals 27, an equal sign, and something on the other side, this is an equation. Think of the word equation. The first 4 letters are the beginning of the word equal. Equations have equal signs. Expressions do not. Up until now, all we've been working with were expressions. They have meaning, but they're not a full statement or an idea. An equation is a mathematical statement where 2 expressions are set equal to each other, and it has an equal sign in it. So here's one expression, here's the other, and they're set equal. Another piece of vocabulary, the solution to an equation. The solution to an equation is the value for the variable that makes the equation true. Meaning both of the sides of the equation will be equal when you put that number in for the variable. Whenever you're asked to solve an equation, that means find the solution. So, for instance, down below, you're going to be asked to find the solution for 3x minus 11 equals 7. So we're going to find what value for x when I times it by 3 and take away 11 will actually give me the answer 7. What will make the 2 sides of the equation equal? Likewise, on all the rest of these problems with an equal sign that say solve, you are finding the solution, the number or numbers that work to solve the equation to make it true on both sides. Now, the last thing I want to talk about before we swing into solving and a little bit of background is law of equations. You need to think of an equation like a balance scale. And on a balance scale, we need to make sure both sides are always equal. So if we do something to one side of a balance scale, we take something off or we put something on, we must do the same thing to the other side. So as you're working on equations, I'm going to continually remind you, are you doing the same thing to both sides? Let's look at that with an image. I've got a picture of a balance scale here. And you can see that if there are 12 plus 50 pounds on this side, and 62 grams on this side, we get grams on both sides, that the balance scale would balance out. It would be equal. So I can even write an equation that represents this. 12 plus 50 is equal to 62. Now, let's say I decided I wanted to add some weight to both sides. Let's say I added 25 pounds to this side of the scale. I put 25 pounds on here, plus 25. Now, here's what I'm going to do. I'm going to draw a line below my equal sign to show the 2 sides of the scale, the 2 balanced parts of the scale. If I add 25 to this side, my scale is going to tip that way unless I likewise add 25 to this side. So this is how it would look if we were working on this equation numerically. And so now we'd have 12 plus 75 equals 87. Is it true? I think so. Yep, we're going to get 87 equals 87. We must always do the same thing to each side of an equation to keep the 2 sides equal. Likewise, let's say, different scenario. Let's say I had my original balance scale with 12 plus 50 pounds on one side and the 62 grams, I keep saying pounds, sorry, on the other side. And I decide I want to take 12 pounds off of this side of the scale. Well, the scale is going to tip this way if I don't also take 12 pounds off of here. Now, it'd be a little bit difficult since all my weight's contained in one solid mass. I'd have to break this apart into pieces or put different weights on until they added up to 62. And then I would be taking off 12 pounds from both sides. Here's what that looks like in our equation solving steps. To take off, whoops, I want to put that underneath here. Take 12 off of both sides. And so these 12 pounds would be gone, and I would get 50, and 2 minus 2 is 0. I'd have 50 pounds on both sides. Now this seems perhaps overly simple, but when we're solving equations, it's going to look very similar, only we might have something like this instead. X plus 50 equals 62, where this amount of weight is unknown. And how would we solve it? Well, if we take 50 grams, off of this side, and we take 50 grams off of that side, then we'd be able to find what that missing amount of weight is. If we take this away, then we'll have this alone, and we can find the weight of this all by itself. So what I do to one side of my scale, I do to the other, and I will have X equals 2 minus 0, 6 minus 5, 12 pounds. I'd find the mystery number. So it's a very simplified explanation so far, but just keep in mind the whole point of this was keep your equation equal on both sides, like a balance scale. Turn into the next video and we'll start solving equations.